So, good morning, students. Let me continue with this similar Pythagoras theorem for 10th class state and Cbse. In an isosceles triangle ABC, AB is equal to AC. In an isosceles triangle AB is equal to AC, BD is perpendicular from B to side AC. Prove that BD square minus CD square is equal to 2 times CD into AD. In an isosceles triangle ABC, AB is equal to AC. AB is equal to AC and BD is perpendicular from B to side AC. BD is perpendicular from B to the side AC. Prove that BD square minus CD square is equal to 2 times CD into AD. So, once again I will read out the question. In an isosceles triangle ABC, AB is equal to AC and BD square minus CD square is equal to 2 times CD into AD. That's all. In an isosceles triangle ABC, BD is perpendicular to AC. Prove that this one they are asking. So there is no construction in this. Directly we have to do the problem. Consider triangle ADB. Right? ADB. In this triangle, angle ADB is 90. Angle ADB is equal to 90. Apply Pythagoras theorem. So square on the hypotenuse is equal to sum of squares on the other two sides. But I want BD square. See here, BD square is there. So BD square is equal to AB square minus AD square. This square minus this. Hypotenuse square minus the other side will give this one. Right? So now BD square is equal to AB. What is AB? In an isosceles triangle, AB is equal to AC given, no? AB is equal to AC, right? So in place of AB, I can write AC square minus AD. Since AB is equal to AC given, right? Now AC length how will you get? By adding AD plus DC. This complete length, how will you get? By adding AD plus DC. So AD plus DC whole square minus AD square, right? So BD square is equal to A plus B whole square. So AD square plus DC square plus 2 times AD into DC minus AD square gets cancelled. So BD square is equal to DC square plus 2 times AD into DC. Now bring this here. BD square minus DC square is equal to 2 times AD dot DC. So here BD square minus CD square is equal to 2 times CD into AD. And is the theorem. Very simple. Nothing is there in this problem. Only I have applied A plus B whole square and Pythagoras theorem. Next problem. So is it clear? Should I explain once again? They are given right angle triangle, square on the hypotenuse is equal to sum of, but I want BD square. Here keep in mind what we have to prove. BD square is equal to squares on the hypotenuse square minus this one. But hypotenuse, this AB is nothing but AC. So AC is there. In place of AC, I will get AD plus AB, A plus B whole square. So that's it. Another question. So ABC is a right angle. ABC is a right angle at C. If P is the perpendicular, if P is the length of the perpendicular from C to AB, they are given ABC is a right triangle at C. Here right angle at C. P is the length of the perpendicular drawn from C to AB. So ABC minus D. So P is the length of the perpendicular drawn from C to AB and AB is equal to C. AB is equal to this complete length is nothing but C. Next, AB is equal to C and BC is equal to A. Next, AC is equal to D. Prove that, what they are asking is, prove that PC is equal to AB. Prove that PC is equal to AB, and 1 by P square first bit, second bit, 1 by P square is equal to 1 by A square plus 1 by B square. So apply area of triangle formula. What is the area of triangle? Half into base into height. For this right angle triangle, apply area of triangle formula. Area of triangle in which BC is base. BC is base. So what is the formula? Half into base into height, AC. Right? Half into base is nothing but A into height is nothing but B. So leave it until here. Until here you leave it. Next, area of triangle ABC in which AB is the base. In which AB is the base. So what is the formula? Half into, when you take this as base, half into base is AB into height is CD. Height is CD. Now they only gave this BD is CD is drawn perpendicular to AB. So mark this as 2. So whether you rotate the figure like this, or whether you rotate the figure, whether it is standing straight like this, or if you rotate like this, area will remain same. So therefore from 1 and 2, the area of triangle remains same. Whether you turn upside down, you turn, it will remain same. So this is equal to half into AB is equal to half into, here I did not write, half into AB. AB is nothing but C into CD is nothing but C. Half into C into B. CD. CD is nothing but P, I am sorry, P. So half of cancel, AB is equal to PC. First bit is over. So PC is equal to AB. Right? Second bit. Are you following what I am saying? If you rotate the figure, area remains same. That is the main point we should remember. For this area of triangle, half into base into height. For this triangle, again if you take this as base, this becomes the corresponding altitude. So equate both, areas are same. So first bit is over. AB is equal to PC. Second bit. Second bit is quite simple. So bring this. Here what you have to do, see here 1 by P square is there. So P you keep as it is. P is equal to AB by C, right? Now invert 1 by P is equal to C by AB, right? Invert this one. Now square on both sides. So 1 by P square is equal to C square by A square B square. Now this is a right angle triangle, right? So apply that formula, Pythagoras theorem. Angle where angle C is 90 degrees, square on the hypotenuse. So AB square is equal to AC square plus BC square, right? So AB is nothing but C, they gave the length. C square is equal to AC is nothing but B. B square plus BC is nothing but A. So B square plus A square. So in place of C square, what you have to write? 1 by P square is equal to, in place of C square, you have to write A square plus B square by A square B square. In place of C square, what you have to write? I am saying A square plus B square. So that's what I am doing. Now this can be written as 1 by P square is equal to A square by A square B square plus B square by A square B square. Both denominators are same, so I can add the numerator. That means I can split this into two parts, fractions. So 1 by B square is equal to 1 by B square plus 1 by A square. So 1 by B square is equal to 1 by A square plus 1 by B square. That's it. There ends the problem. Next problem. So it is very simple. There is no confusion at all. I think this is one of the important problems they may ask for exam. Please make a note of it. Another question. From a point O on the interior of triangle ABC, perpendiculars OD, OE, OF are drawn to the side. Prove that they are asking something. From a point O on the interior of triangle ABC. From a point O in the interior of triangle ABC, this is the point O. OD, OE and OF are drawn to the sides BC. BC is what? OD, OE, OF. From a point O in the interior of triangle ABC, perpendiculars OD, OE and OF are drawn to the side BC, CA and AB respectively. Prove that they are asking very important question. Prove that AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OF square. First, let us prove this one. Join this. In order to prove this one, you have to join this one. So, are you following the question? Triangle ABC is there. He took O as some point. From O, they are dropping perpendiculars. Prove that they are asking AF square plus BD square, AF square plus BD square plus CE square, AF square plus what is that? AF square plus BD square plus CE square is equal to this they are asking. So how to do this one? How to do this one, children? So AF square, consider this one AF square. Right? So this is a right triangle. Consider triangle AFO. Right? Consider triangle AFO. So for this is the hypotenuse, right? So how will you get hypotenuse? This square minus this one. OA square is equal to, what I am saying is, this is right angle, this is the hypotenuse, right? So OA square is equal to, write down like hypotenuse square is equal to AF square plus OF square, right? Square on the hypotenuse is equal to sum of other two squares on the other two sides, AF square plus OF square. So here he is asking AF square. So what you have to do is, write down AF square as it is, bring this to here. OA square minus OF square, right? So next, consider triangle AFO. Next, consider triangle, which triangle? BD is there. So this triangle you have to consider. Consider triangle BDO, this one, right? So in the same way, this can be written as BD square is equal to hypotenuse square OB square minus OD square. Similarly we can write. Next, consider triangle BDO is there. CE square, CE. Here it is CE square. Consider triangle COE, right? COE. So how will you get COE? Consider triangle COE. Square on the hypotenuse. So this becomes the CE square is there. CE square. CE square, how will you get? CE square, how will you get? This is a 90 degree. This angle is 90 degree. CE square, how will you get this one? OC square minus hypotenuse square minus OE square. So mark this as 1, mark this as 2, mark this as 3. Once again I will explain. So here AF square is there. Consider triangle A, this one triangle you have to consider. AF square is there. So hypotenuse square minus this square will give this one. You can write directly this one. Next BDO. BDO. Why we have to take this triangle? Because see in mind what we have to prove. BD square. So BD square is equal to square on hypotenuse minus OD square. Next COE. Why we have to take this one? Because C square given. So C square I will get square on the hypotenuse minus this one. So add all these three. Why we have to add? Because they are given this one. Adding 1, 2, 3. Adding 1, 2 and 3. Adding 1, 2 and 3. So AX square plus BD square, AX square plus this one, AX square plus BD square plus CE square. So it is equal to OA square plus OB square plus OC square. So see here we are getting, already we have 90% of the problem is finished. Minus OF square minus OD square minus OE square. See here OD square is there, OC minus OD square, OE square is there, OD, OE, OF. So this ends the first part is over. Second part, what is asking? First part is finished. Very simple. You have to consider these triangles and we have to prove that the given condition. Next one, second bit is also there. What is second bit they are asking? AF square AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. This is second bit. So this remains as it is. See here AF square BD square plus C square. This remains as it is. So AF square plus BD square plus C square is equal to, from this what you can say is OA square is this one, OA square minus OA square minus OF square, OA square minus OF square. OA square minus, what I am saying is just interchange this one, OA and OE. OA square AF square plus BD square plus CE square is equal to OA square, club these two, OA square minus OE square, OA square minus OE square, because see in mind what we have to prove, AE square. So OA square minus OE square, this is one part. Next OB square, OB square, come to this part, OB square, what you have to do, CD square is given. So OB square is there, and which one you will group now, OB and OF, you group OB and OF. OB and OF, OB square minus OF square. OB minus OF is nothing but BF. Just 1 minute. Yes, OB minus OF, you group these two. Next, plus what is the other part? OC square minus OD square. So from this only, what I am saying is, from this condition only, what we have to do is OA square minus OE square, OA square minus OE square. See in mind what we have to prove, AE square is given. So if you subtract OA square, you will get AE square. Next, OB square minus OF square. From this condition only I am writing this, OB square minus OB minus OF. You will get OB square minus OF, club these two. Next, OC square minus OD square. OC is not OC, OC square minus OD square. Now, this LHS is remains same. OA minus OE. OA square minus OE square. Square on the hypotenuse. They are subtracting this minus OE square. You will get AE square. AE square. Plus OB square minus OF square. OB square minus OF square. So square on the hypotenuse. You will get BF square. Why you will get BF square? You can write next step. Are you following what I am saying? Square on the, for this is the hypotenuse. So OB square minus OF square is nothing but BF square. Right. Next, plus OC square. OC square minus OD square. OC minus, what is that? OC minus OD is nothing but OC square minus OD square is nothing but what will be DC square. So how we are writing this step is, since you can also write AE square is equal to, for this triangle, this is the hypotenuse, AE square is equal to OA square plus OE square, right? So AE square is equal to OA square plus AE square, right? OA square minus OE square. So here I'm sorry. So I am saying that already theorem is proved, but what I am saying is OA minus OA. OA minus OE is nothing but AE square. So here OA square is equal to, for this is the hypotenuse, OA square is equal to OE square plus AE square. So from this again, are you following? Next, OA square minus OE square is equal to AE square. So in place of this, why I am writing AE square, I am explaining that part. OE square is AE square is equal to this square minus this square. Next, in the same way, OB square minus OF square. OB square minus OF square. This one, why are you writing BF square? Why? What is the reason? BF square. So for this is the hypotenuse, right? So OB square, square on the hypotenuse is equal to BF square plus OF square, right? So OB square minus OF square is nothing but BF square. OB square minus OF square is BF square. There ends the problem. So thank you students. We will continue in the next class the other similar triangle, the other Pythagoras theorem. Please don't forget to subscribe my channel. Click on the blue color icon button. Have a nice day. Bye.